Institute of Health is our big organization that hands out billions of dollars to scientists who ask for grants to get the money to do what they want to do. It's what I can't do. There's no way I can put in for a grant and get any money to do anything. Get that. Get out of our sight. We don't want to even think about you, much less give you money. But they can, and they do, to sequence anything they want. But because it's government money, they are obligated to send the results to the National Institutes of Health, which gives them the money. So every genome that's been sequenced in the last 4 or 5 years by these machines that you saw is recorded in the NIH database. They have over 140, and they're adding new ones all the time, species types, like a dog, like a cat, like a cow. And then they have thousands of species within those species types. You know, different kinds of dogs, different kinds of cows, different kind of bacteria, different kind of viruses. They have trillions, try to keep this number in mind, trillions of coherent base pair sequences logged into the NIH database. So that when a geneticist gets a new sequence, all he does is log it into the NIH, and the NIH tells him where it fits on the genome, on the chromosomes within the genome of something that's already been sequenced. It's real easy, and it's real quick, and it's very efficient. So he sent the samples, a few dozen of the Star Child shotgun recoveries, to the NIH, and sure enough, came back. Some of them were indeed human. Some of the Star Childs knew. This is a 265 base pair string. Homo sapiens, if you can't read it, it's chromosome 1, genomic contiguous, just saying where it is. This one happens to be on chromosome 1 of humans. But this is representative of dozens. I could put dozens up here, but it would just get boring. Okay? But some of them, to their great surprise, a DNA segment 342 base pairs long, that's a pretty good size, proves some nuclear DNA is not human. No significant similarity found. See it? For reasons why I click here, and I'll explain. No significant similarity found. This means some of the Star Child's nuclear DNA cannot be found in the NIH database that contains trillions of base pair segments from thousands of species on Earth. Draw your own conclusions. Is that alien or is that not alien? What would you call that? I think it's alien. For reasons why I click here, this refers to a list of possible errors in the submission process. Our geneticists obtained the same results with multiple samples, so he has no doubt that he did them correctly. You do it enough and you get the same answer. You know you're doing it right. So, glory, hallelujah. Now, that's kind of hard to read. This is a different thing. I just asked, is there a different form we can get so it's easier to see? And he got this back. This one is 232 letters, but it's still the same thing. No significant similarity found. This is it, folks. This is history as big as history can be made. This is landing men on the moon. This is proving aliens exist. This is proving an alien was real 900 years ago and lived and died and was buried on this earth. So you are the fourth audience that I've been out to tell this to. Fourth. So it isn't that widely known. It's on the website and all that, but it's spreading out. But you're early into the game here as far as this goes. And I hope you appreciate that. It's really cool that you're here and you're getting to find out about this. Now, this is something else that he did. He's done this more recently. I said, well, can you do anything else besides that? So he did a spectrophotometer reading for human DNA and Star Child DNA. Now, it's just light passing through. You don't need to know what it is. This is the result. This is absolutely purified human DNA. This is what it's supposed to look like, or something close to that, right? And you can see the Star Child's does look close to that. But it's like well, I want to be human so bad, but I just can't quite make it, you know. But I'm human enough. You can kind of see it just kind of, I'm not there. You know? But it's there. It is there. It is there. You know it's there. But when he did it, ran it through electrophoresis analysis, the gel sheet, a different kind of gel sheet analysis, specifically for human. This is what perfect human looks like. Front edge, rear edge, and all this in between. So the Star Child should look something like this, and this is what it looked like. Nothing. He was very surprised. I mean, very surprised. I don't know what that means. It just means that more of it is different than we thought. Now, let's understand what he's done here. He's recovered in the range of about 30,000 when you add together all the hundreds and the couple thousands that he's had. About 30,000 of the base pairs have been recovered of the 3 billion that we need. Now, imagine, if you would, that this is like the 3 billion is like a loaf of bread. A loaf of bread. He's cut off a very thin slice off the end. From what we need, what he has is a very thin slice. And he said, you give me 15 years, I can do the whole loaf of bread doing it by shotgun. But it's stupid because those machines are out there. We just have to pay for them. But he said, I can shotgun it for 15 years and I can get it. But we obviously want to do it with a machine. But he says that thin slice is enough to know what the loaf of bread is. You can smell it, you can feel it, you can taste it, you can see it. And you know what you have. And it's not a human loaf of bread. It's not a chimp loaf of bread. It's not a gorilla loaf of bread. It's not a Neanderthal loaf of bread. It is different. And we can prove it. That's what this is all about. So, where are we now? Trying to figure out how it happened. How did it happen? Can humans and aliens procreate? All right? Can they get together and make a baby? Well, yes, if the difference between the two of their genomes falls within 3%. Why do we know that? Because a chimp and a human's genomes are 97 to 98% the same. You get arguments. Some people say it's 2% different. Some people say it's 3% different. I go with 3%. Let's just say 97% the same genome chimps have and we have. 3% difference. There is no way that a chimp and a human can make an offspring. So that we know that if this is happening, that has to fall within that 3%. We have always assumed that the star child, when its genome was recovered, we had hoped that it would fall closer to 3% than to the 99.9% that all of us are. We're all 99.9% the same. You get some arguments and people are trying to say, well, maybe it's 99.8, 99.7, but you hear most consistently 99.9. We're almost clones. We're so alike. That little bit makes all the difference in all of us, right? But if you look at 3% makes us, the difference between us and chimps, that sort of makes sense, doesn't it? Because there's a lot of difference between us and chimps. And gorillas are 95%. 5% difference, 95% the same. Rats are 70% the same. And a lot of animals are the same. It's all blended in together. The same material is used over and over again in various species. Lots of different species. So for this, it's got to fall within 3%. We're hoping it's falling closer to the chimp because if it falls real close to the humans, what are the scientists going to say? It's just a variation. It's just a freak. But if it's over near a chimp, it's pretty hard to make that argument, right? So we always felt that if it came in closer to 3, we would win. If it came in closer to 99.9, they would win. All right? So I say to him, given what you have, where do you think the difference is going to be if we're talking procreation? He says, oh no, we're not talking procreation. The difference is going to be between 10 and 50%. Between 10 and 50%. Now that's a big margin because he only has a little bit. But he says if you just extrapolate it out, that's where it's going to fall. Probably in the range 15, 20, 25. So very different that it's not even a question that it's an alien. In fact, it may be all alien except for the mother. Now I know what that sounds like. We're just speculating now. I know. She said, what? I was the same way. What? You know, but this is where it is. This is going to blow you away, but this is where we are right now. Subject to change. Subject to the loaf of bread. But this is what we're looking at with the small part that we have, the slice that we have right now. Human and chimp genomes, just so that you know the difference. This is a little sidetrack, but it's very interesting. Human and chimp share everything the same pretty much, but there are some significant differences. The main one being that all higher primates, chimps, gorillas, right on down, have 48 chromosomes. 48 chromosomes, 24 from each parent. We are the only higher primate with 46. Where did those 2 chromosomes go? And if that's a lot of DNA. And if those 2 chromosomes went, how do we still share 97% of the same genome and 95% of the same genome with gorillas? How do we do that? Well, the truth of it is, the 2 chromosomes that we're missing are not missing. They have been altered. You'll notice that the 2nd and 3rd primate chromosome in a human has been fused. Somebody has neatly clipped off the telomeres and fused it back together, those 2 ends together, such that they continue to function. Now, genes are sensitive things. You have to know just what you're doing to make it work right. And to do that is really an amazing thing. And guess what? Nature can do anything. Nature can do anything. That's what they tell you. I'm telling you. You confront them with this, they say nature did it. Nature can do anything. We can show you other examples of that, and sure, nature can do that. It's only done in domesticated plants and animals where you see weird things happen in the genomes because they were genetically engineered. That's the truth of it. With humans, guess what? Some of these other, 9 of these other chromosomes, segments have been taken out, taken out, flipped in on end, and put back in, and and glued back. Boy, I really hit a lot. And glued and put back in. Taken out, flipped over, and put back in. 9 other ones. And on top of that, if everything evolved the way they say it did, we should have everything somewhere behind us, right? Of our 25 or 30,000 genes, we have 232 genes not found in any other species anywhere else on the planet. Where did they come from? You know what scientists say? Well, we must have been infected by some exotic bacteria that left their traces and then went away. Occam's razor. I have made fire. I have thought of a simple answer. You know, it's just ridiculous. So this is just to show you that this is my other work. This is the work I love, you can tell. The human origins, hominoid, stuff like that. This is what I really like. But I won't hit you with any more of that, because if you don't know about this, it's got to be a hammer shot for you. I know that. Okay, so we're talking about if we can't have a sexual offspring, it has to be in vitro. The star child then turns out to probably be in vitro. If it's that big a difference, it couldn't be anything else. And we're doing that now, and it's test tube babies. You know how it works. It isn't that hard, so it wouldn't be for a higher race of beings to do it 900 years ago, or 9,000 years ago for that matter, or 200,000 years ago when we were created. All right, so I said, well, okay, how would it happen? How could it possibly happen that you have something that's so heavily alien, and you can look, there's nothing hardly left of the human in the skull, it's dominantly alien, but how can you get something so heavily alien coming out of a human mother? And so he said,